Aside from the obvious benefits of running across multiple nodes, horizontal scalability, resilience, application proximity, reduced latency, and regulatory compliance, lies another incredibly useful benefit to CockroachDB's distributed nature. You can ask CockroachDB to task specific nodes with specific responsibilities. For example, perhaps you might want to ring fence a subset of your nodes for the purposes of archive, or perhaps you only want to run analytic queries on a subset of your nodes. Or perhaps you want to designate a subset of your nodes for the purposes of SQL queries, optimizing their CPU and memory and limiting the amount of data they store. These all provide cost optimizations, especially if you have large clusters with lots of data and variable workload patterns. But regardless of your workload, today I'll show you how CockroachDB makes all of these scenarios trivial to implement. We'll start with the hot archive scenario, whereby an application will be talking via load balancer to a pool of live nodes, but in the same cluster, I'll designate a subset of nodes to act as archival nodes. These nodes here will only store old data, and as the amount of old data increases, so too can the pool of archive nodes. And you might want to house these nodes on cheaper hardware, perhaps larger, slower disks, whereas these nodes might receive better CPU, memory, and faster disks like SSD. But they won't grow as quickly as the archive nodes, meaning you have a cost optimization based on scale. I'll show you the demo so you can see what I mean. First, I'll start and initialize a 3-node cluster. These will be our live production nodes. So these might want to be on slightly better hardware, and they're listening on ports 26101, 02, and 03. I'll spin up a load balancer. You'll want to configure your own load balancer for this, and I'll target those 3 nodes. Next, I'll create some database objects. I'll be simulating an e-commerce workload. I'll generate a bunch of data, and I'll start an e-commerce workload. With this workload running, we have this setup here, an application talking to a load balancer to our live transactional production nodes. Let's create some archive nodes now, and then tell CockroachDB what it should consider to be archive data. In this scenario, anything with a dispatched status that's greater than 7 years old, I'll consider archive, and I'll physically move to those machines. And just to recap on why this is important, typically if you're archiving old data, you might be doing so to tape storage or some medium of storage that's harder to access than if it were within the same cluster that you run the rest of your production workload. In this setup, I can query that data just as easily as I can query live production data, but it has much less of an impact on my live production data than it would if it was on the same nodes. Let's connect to CockroachDB and get a feel for how much data needs to be archived at the moment. Currently, there's only 1,830 rows, but over time that will grow. Next, I'll create a store procedure that will scan through the table in chunks of 1,000 rows at a time, looking for anything with a dispatch status that's more than 7 years old. It will then change that row's status to archive. I can set up a schedule for this, currently outside of CockroachDB, but in the future, I'll be able to create a recurring job that does this for me. Next, I'll create an index on the status column, onto which I'll create a list partition. Anything with the status of archived, I'll move to the archived partition. Otherwise, I have a default partition for everything else. And finally, this is where the magic happens. I update the table's zone configuration using the partition, ensuring that the archived partition only lives on nodes that have an attribute of archive. This will currently fail because I don't have any nodes in my cluster with this attribute. So if I run this, it can't satisfy the constraint because there are no nodes within the cluster that have the archive constraint. Let's fix that by adding 3 new nodes with the archive attribute. With this command, I join 3 new nodes to the cluster, listening on ports 26201, 2, and 3, all started with an attribute of archive. This is just an arbitrary string, but it allows me to control CockroachDB's replication once it's joined the cluster. With those nodes part of the cluster now, I can rerun this. And I'll also run the reverse, so store data for the default partition, i.e. everything else, on nodes that don't have the archive attribute. Let's take a look at the partitions now, so we can get an idea as to what the data looks like. We can see that for the table, there are 2 partitions, the archived partition, whose constraint only allows CockroachDB to store on nodes with the archive attribute, and the default partition that does the reverse. It stores everything that's not in the archive partition on the remaining nodes. If we take a look at the ranges now, we'll see that currently the default partition for range 71, the number of ranges will increase as the dataset increases, currently lives on nodes 1, 2, and 6. whereas our archived data is currently empty. We haven't specified anything to be archived yet, doesn't have any rows, and is replicated across nodes 1, 4, and 6. If I run the query again, we'll see that CockroachDB was currently in the process of removing that data from those replicas to just leave the archived data on nodes 4, 5, and 6. Let's run the store procedure now to convert those old dispatched rows to archived rows. And with that, we've moved 2,200 rows to archived and hence moved physically to the archived nodes. Let's rerun our range query, and we can see now that our archive nodes 4, 5, and 6 contain the 2,285 rows that we just marked as archived. This is one way of archiving data. We also have partial indexes that allow you to index a subset of your data if you would like all of the data replicated across the same nodes. If you don't care about the data anymore, we also have row level TTL that allows you to expire rows, physically deleting them from the cluster after they reach a certain criteria. In our case, dispatched and more than 7 years old. Give constraints a try for your use case and see how they can benefit your workloads.